Look up at the night sky. Among the countless stars there's a small reddish dot, Mars. For centuries it's captured our imagination. Could we ever go there? Could we ever live there? This isn't just fantasy, it's one of humanity's greatest challenges, turning a cold, dead world into a second home. Earth is beautiful, but our curiosity is boundless. We are explorers by nature. Our ancestors crossed oceans. Now the horizon is the edge of our solar system. Mars is our next great voyage. A chance to prove life isn't confined to one world. Imagine waking up to a pink sky, stepping onto red plains slowly being transformed. This is the vision of a terraformed Mars, rivers carving new canyons, forests reaching for a once-empty sky. It's not just science fiction, it's a potential future, a story of creation written by us. Terraforming is the art and science of planetary engineering, changing a world until it becomes like our own. It would take centuries, maybe millennia, and technology we haven't invented yet, but the dream persists, a dream of survival, expansion, and exploration. The story of terraforming Mars is the story of us, reaching for the stars. It's about our ingenuity, courage, and ability to work together on a cosmic scale. Imagine children running under a new sun, forests growing where there was only dust. This journey is more than survival. It's about fulfilling our deepest impulse to explore. The cosmos is vast and so is our ambition. Mars could be our second home if we dare to try. What is terraforming? The word means earth-shaping. It's the process of deliberately changing a planet's environment, its air, temperature, and surface, to make it habitable for Earth life. Think of it as a planetary-scale renovation. You're not just building a house, you're making the land itself. Imagine a barren garden plot. Dry, hard, nothing grows. To make it bloom, you enrich the soil, add water, and warm the air. Terraforming is the same idea, but on a planetary scale. The garden is Mars, and our tools are giant mirrors, factories, and engineered life. At its core, terraforming is about starting a chain reaction, kickstarting key processes, then letting the planet's own physics do the rest. For Mars, this means triggering a greenhouse effect, not the dangerous kind, but a beneficial one. By warming Mars, we could release frozen gases, thickening the atmosphere and trapping more heat. It's like nudging a sleeping planet, hoping it wakes up. This is a delicate dance between biology, chemistry, and physics, not brute force but working with natural systems. We'd introduce the right microbes, then plants, each step building on the last. The first note, a rise in temperature, the crescendo, flowing water, and a living world. Terraforming is the ultimate test of our ability to understand and shape our environment. It's a symphony of science, engineering, and imagination, and it all starts with a single spark. The dream of a living Mars began long before we sent robots there. In the 19th century, astronomers like Percival Lowell imagined canals built by Martians, a world once lush and Earth-like. The canals were an illusion, but the idea sparked our imagination. Science fiction writers ran with it, painting Mars as a place of adventure and mystery. These stories planted a seed. Mars could be, or could have been, a place for life. The scientific idea of terraforming came later, as probes revealed Mars's true nature. In the 1960s and 70s, thinkers like Carl Sagan asked, could there be life on Mars in the future? Sagan proposed warming the planet and thickening its atmosphere. Scientists replaced fantasy with real-world physics, greenhouse gases, atmospheric pressure, and engineering. Ideas like spreading dark dust on the poles or building giant mirrors became the first blueprints. Terraforming shifted from science fiction to scientific inquiry. We learned to see Mars not just as it is, but as it could be. The dream of a green Mars endures, fueled by both imagination and science. Before we can green Mars, we must face its harsh reality. Mars is a world of extremes, a planetary obstacle course. The first problem, cold. Mars is far from the sun, and its thin atmosphere can't hold heat. Average temperature minus 62 Celsius. Even at the equator, nights plunge to minus 73. The air is thin, about 1% of Earth's. You couldn't breathe it, it's mostly carbon dioxide. The thin atmosphere offers no protection from the sun's radiation. Mars lacks a magnetic field, so cosmic rays bombard the surface. Water is locked away as ice at the poles and as permafrost underground. Liquid water can't last on the surface, it boils and freezes instantly. The soil is toxic, filled with perchlorates, and lacks the organic matter Earth's soil has. To grow anything, we'd need to warm the planet, provide water, and clean the soil. Each obstacle is monumental, but not insurmountable. Mars challenges us at every turn, but every challenge is a chance to innovate. The path to a living Mars begins with overcoming these extremes. How do we start terraforming Mars? First we warm it up. The goal: raise the temperature enough to melt the frozen carbon dioxide at the poles. Released CO2 thickens the atmosphere, trapping more heat, a feedback loop. One idea: giant mirrors in orbit, focusing sunlight onto the polar caps, vaporizing CO2. It's planetary-scale solar power, using the sun's energy to kickstart warming. Another approach: build factories on Mars to pump out super greenhouse gases like perfluorocarbons. These gases would act as a high-tech blanket, warming the planet faster. Or we could darken the polar ice by spreading dust, making it absorb more heat. Each method has pros and cons, but all aim to end the Martian ice age. The first step is simple: turn up the thermostat. Once Mars starts to thaw, the real transformation can begin. Warming Mars is the key to unlocking its potential. The journey starts with a spark of heat. As Mars warms and its atmosphere thickens, the next challenge is making the air breathable. A CO2-rich atmosphere traps heat, but we need oxygen. On Earth, oxygen came from billions of years of photosynthesis by microbes. On Mars, we'd need to speed things up by seeding the planet with life. The first pioneers: extremophile microbes engineered to survive Mars's harsh conditions. Their job: perform photosynthesis, turning CO2 into oxygen. It's a slow process. Generations would pass before oxygen levels rise. As oxygen increases, it reacts with the Martian soil, changing its color. Eventually, an ozone layer would form, shielding the surface from deadly UV radiation. Only then could more complex life take hold. The transformation would be gradual, but each step brings Mars closer to life. Breathing on Mars would be the ultimate sign of success. The air we make would be the breath of a new world. With a warming planet and thickening atmosphere, the next ingredient is liquid water. Mars's water is locked as ice at the poles and underground. As Mars warms, ice melts, first forming briny pools in craters and basins. Water vapor is a greenhouse gas, so more water means more warming. Clouds would form, rain and snow would fall, washing toxic salts from the soil. The planet would begin to heal itself, but managing water is crucial. We'd need to direct its flow, carve channels, and build reservoirs. Ancient riverbeds could flow again, guided by human hands. The ultimate goal: stable oceans, even if shallow, to stabilize the climate. Oceans would cradle new life, just as on Earth. Seeing blue water under a pink sky would be proof Mars is coming alive. Water is the lifeblood of a living planet. With it, Mars's transformation accelerates. After centuries of work, Mars would finally be ready for complex life. We'd start with hardy plants, grasses, mosses, and genetically modified trees. These pioneers would break up the soil, create organic matter, and lay the foundation for ecosystems. Forests would look different: short, sturdy, engineered for Martian winds. Drones could scatter seeds across the plains, patches of green spreading over red. Plants would become the lungs of Mars, producing oxygen on a massive scale. Their roots would support fungi, worms, and insects, building a self-sustaining biosphere. Each new species would be a carefully chosen step in a planetary symphony. One day, humans could walk Mars without a spacesuit, breathing cool, crisp air. The transformation: a barren wasteland into a living garden. This is the ultimate vision of terraforming, a testament to life's persistence and our hope. Why terraform Mars? It's about more than a backup planet. All of humanity's eggs are in one basket: Earth. Spreading to another world is the ultimate insurance policy. This project would unite us, requiring global cooperation and shared purpose. The challenges could bring us together like nothing else. The dream of a green Mars gives us hope and perspective. The same science that could create a biosphere on Mars can help us protect Earth. Looking up at Mars, we see a canvas, a promise, a future home for our descendants. Terraforming Mars is the ultimate story of exploration, not conquering but nurturing a world to life. It's about curiosity, spirit, and hope for a future where humanity is a citizen of the solar system. The story of Mars is the story of us, written in the stars, and it's only just beginning.